In this video, we'll learn how a rocket moves in free space. Suppose we have a rocket and its engine is turned off. Its initial speed is 0 relative to the Earth. The rocket has mass dm plus m, so its initial momentum equals its initial mass times its initial speed, which we consider to be 0. So the initial momentum of the rocket is also 0. Now we will fire up the engine for a brief dt amount of time. During this time, the rocket ejects dm amount of gas with a speed ve relative to the rocket, and the rocket moves to the right with a speed dv. The final momentum equals the momentum of the ejected gas, which is the mass of the ejected gas, times its speed relative to the Earth. It's negative because it's moving to the left, plus the momentum of the rocket, which is its final mass times its final speed. Our system is isolated, so that means the final momentum is equal to the initial momentum, which is 0. Let's put this 0 right up here and rearrange this. If dm represents the change in the mass of the rocket, then as dm amount of gas is ejected from the rocket will lose the same amount of mass. The negative sign indicates that the mass of the rocket is decreasing. So our equation becomes this. Now let's divide both sides by the time interval dt. dv over dt equals the acceleration, and mass times acceleration equals the force or thrust produced by the engine. dm over dt represents the burn rate, the rate at which the gas is ejected from the rocket. And the negative sign indicates that the force is opposite to the direction of the ejected gas. So the thrust produced by a rocket engine equals the burn rate times the speed of the ejected gas. Now let's see how we can measure the final speed of the rocket. We already figured this out. Let's bring this m on this side. Now we integrate both sides. On the left, we integrate from the initial speed to the final speed, and on the right, we integrate from the initial mass of the rocket to the final mass of the rocket. After we do the integration, we'd get this. This -1 can be placed as the power of this fraction, and that just flips the fraction upside down. And that gives you the formula for the final speed of the rocket. Okay, thanks for watching, and I'll see you next time.